Hi, everybody. It's nice to be here. So I'm Alex from Cloud Academy. So before I tell you a little bit about me, I wanted to ask you something about you. So how many of you have built a data warehouse system ever? 0. 1, 2, 3. Great. So how many of you did it without managing or using servers? Like, serverless, 0, so I'm good. So I'm Alex. I work at Cloud Academy. I have a computer science and web development background, and you can find me on Twitter or LinkedIn. You have the links to the slides if you need any reference or URL at hand. So let's get started. So I want to talk to you about like data analysis and data warehousing. I'm going to use AWS because that's my platform of choice today. I will tell you why you may need a data warehouse in your system, what is a data warehouse, and I will discuss all about little details like data lakes versus data warehouses, and then show you my reference serverless architecture. If we have time for QA, otherwise you can find me during lunch break in a few minutes. Okay, let's get started. So why you may need a data warehouse system? So there is an hashtag in each section. Here is big data. So what do you usually do with a data warehouse? So you want to have some kind of repository where you can store all the data that kind of happen in your system. And so we are not talking about a production database where you have your production objects. We are talking about, for example, events that happen that you don't want to have in your production database. It's usually a tool used by data analysts or data scientists for reporting or for DDDM, let's say data-driven decision making. So you want to look at the data, visualize it, take decisions based on what's going on in the system. It's very often used for data analysis, again, and you might use this aggregated or raw data for even machine learning, for training your models. For example, that's what I do. It's an interesting system because you have all this data coming from different external systems. So you may want to integrate data from like invoicing or payment systems or customer support or, I don't know, the weather if you need it. So you may have a lot of different formats, a lot of different, even different needs and users. So it's quite a fascinating type of system to me. You can do a lot of this stuff with a production database. So if the system is really small, you can do analytics, you can count stuff, you can see trends, so you can do a lot of even real-time stuff in your production database. When things get a bit bigger, when you have a lot of users, a lot of events happening, a lot of things happening, you want to maintain the state, the current state in the production database and have all this historical series of events in your data warehouse. So the size of the the volume can be really different. So they call it big data. So the question is, how big is your data? I mentioned that the volume of your production and your data warehouse databases could be really different. So I wanted to provide an example. Imagine you have your production database with, say, 1 million objects. And imagine that for each of these objects, you have like 100 events per day. That's not crazy scale, right? Imagine the system goes on for 3 years, and that each event is 1 kilobyte. Not crazy data. You end up after 3 years with like 100 terabytes of data. It's small database in production. If it goes on average with this kind of okay numbers, you can end up with a huge data warehouse. Of course, you don't have to keep all this data, but it might eventually be useful. So storage is cheap. You can archive it, delete it if you really can't afford it. So I mentioned that one of the goals is data-driven decision. So the second question is, how correct is your data? Because this keeps happening. Like your boss will ask you for a report. You hand over some your analysis, and sometimes he will ask you, is it correct? Like, you never asked before, so I have to recheck. So you want to make sure that this data is correct all the time, that you can validate it, that you can manipulate it if needed, because events are not always managed correctly by developers or by the system. You will miss or have duplicates. It's a complicated problem. So you want it to be accurate, so that whoever queries this kind of system can have a good basis for data-driven decisions. And then this is the other problem of this kind of systems, where you think you have seen something interesting, but it's really just garbage. So there is a saying like garbage in, garbage out, but it's really about who is looking at the data, and that's why the data should be both correct and easy to use and easy to understand, easy to visualize. So my suggestion here is spend time with your data and try to understand it before taking important decisions. That's valid in general, not just with serverless. So if you have this, you can also add intuition and context to this kind of analysis, and that's where it gets useful. So quick parenthesis. What's a data warehouse? What's a data lake? What's the difference? Sounds like a buzzword challenge here, but so there is this distinction that we have to make, because sometimes people get confused, like what is a data warehouse and what is this new strange thing called a data lake? So there are some clear distinction. You can think of a data warehouse as a very structured kind of system where you only have structured data, that it's a big silos. You may want to scale it horizontally, but it's not super easy. It's kind of rigid, very expensive to scale up. Usually very friendly system for business analysts and not people that take decisions. So that used to be the normal. Now we talk more about data lakes. It's not a replacement. It has different goals and different rules and different. It's a different approach. It really can contain any kind of data. So you have this object storage, for example, that you can use. In AWS, we would use Amazon S3, so you can store anything. CSV files, images, JSON objects, whatever you have, you throw it into the lake. And then it allows you to be agile and to literally throw anything at it. It can get really cheap because storage in object storage is cheap. And it's really friendly for data scientists that need all this diverse kind of data, structured, unstructured, relational, not relational. That's up to you. So usually in data warehouses, you have this big problem that storage and compute are bound together. So that's why it's hard to scale. If you want more storage, then you also have to purchase more compute power. Or if you need just more compute power, then you have to double storage as well. The really nice thing of data lake is that these two are separated. So here you can see the two approaches, and I've put some references in the Amazon world. So you would have Redshift for a typical traditional data warehouse. You would have S3 for storage, Athena for the compute layer to build your data lake on AWS. And there is a hybrid in the middle. So you can take the best of both worlds and build your Redshift cluster, but then query stuff on an S3 with a simple Athena SQL queries. So it's an interesting world. You can have a mix. You don't really have to choose. I would go for a data lake if you have to start tomorrow. And let me go back to that beautiful thing of compute and storage separation. It allows you to scale these two components independently. So if you need more compute and not very much storage, you can just pay for more compute. Or if you need to shut down the compute layer for a week because you don't need it, okay, you're just paying for storage. That's typically not how you do it in a regular data warehouse. So that allows you to stay really cheap for storage and still highly available, and scale out compute only when you need it. That's really powerful. And another great advantage is that your data sources in your storage layer can be reused by many different compute layers. So you don't have to replicate data if you have multiple teams or even organizations that need to access the data. So it's really a powerful approach. And this separation allows you to have like a pay-as-you-go compute layer, so that can scale down to 0 if you're not using it. That's why we are talking about it today in a serverless conference. Just funny meme from Star Wars. So you may need a data lake. Okay, I want to show you a reference architecture that I've built personally and show you how it can be fairly simple, then you can extend it and add components to it. So this is what I wanted to build. So I want a black magic box that some event producer would just throw stuff at it, any stuff, and then I wanted my data analysts to be able to, query it and get, interesting results within seconds, not hours or weeks. So this was my very, very simple requirement. I didn't know what would end up being inside it, and it turned out to be nice, in my opinion. So let me tell you a bit more about this system that I was building. So I didn't want to have idle costs. I didn't want to manage servers. We are data scientists in my team. We really don't want to SSH into a machine or stuff like that. I didn't want to have scale limitations, or I didn't want to resize stuff manually. Never do that. Even automatically is awkward sometimes. I wanted to have anonymous event producers eventually. So like imagine a website, so you are generating events, a user clicked or somebody subscribed to the newsletter. You want to track all this stuff to maybe use it later on. I want the storage to be as cheap as possible. I wanted to validate data, manipulate it if needed on the way before it gets stored forever and ever. I wanted to have an intuitive data exploration tool and some way of creating reports so people could take decision over this data. And eventually, that was optional. I wanted to have some sort of real-time metrics, some real-time status of the system what's going on right now or in the last 3 minutes. That this is an interesting requirement that allows you to do like anomaly detection or real-time alerts on data warehouse data. Let me show you what it ended up looking like. It's not crazy. It's fairly simple. It's on AWS. So let me explain it step by step. The components are not a lot. Let's start from the event producer. So these are like browsers, mobile clients, whatever can do an HTTP call, basically. I wanted it to be really simple. I'm optionally using Cognito to get temporary credentials to invoke API gateway. So the first step is usually get credentials, eventually anonymous credentials, but these add some complexity, so you don't get garbage in all the time. Any client that can do an HTTP post request can submit data. And I've put API gateway here, so I can do some validation, eventually credential authentication, or I am even using API gateway to manipulate the body so that the client doesn't need to know what is behind the hood. So it's not a simple proxy here. Behind API gateway, I've put Kinesis data firehose. So Kinesis is the streaming managed service from AWS, so you can use it to handle streams of data. So there is one for video, one for data. Firehose is particularly interesting to me because one, it doesn't have hourly costs, so it's you're charged only based on how much data is passing, not per hour. So it will actually go down to 0 if there's nothing going on. And you don't have to manually write all the logic that will write the data into S3, which is the next component. So I want to store all my data into S3. I want Kinesis to do that for me. And I want it to scale without me setting up shards or stuff like that. It's nice that Kinesis data firehose can invoke a Lambda function for each batch of data that receives. So you can manipulate it, skip it, alter it, or even adding new data. Like if you have some machine learning stuff that you want to do to add a new predicted value, you can put it in there as well. So once it gets into S3, it's there. It's highly available. You can query it whenever you want. You can optionally add more triggers, like invoke a Lambda function for every new file and do other stuff. But the real loop that we are interested in is this one. So we want to use this S3 data. We want to query that data with Athena, which is a totally serverless SQL interface over your S3 objects. So you can configure the table, add the schema, or discover the schema with Glue automatically, and write your SQL query over your like JSON or CSV or what Parquet objects on S3. And it will scale out automatically. So if you have 100 megabytes of data, it will take maybe a few seconds. If we have 100 gigabytes of data, it will take, maybe like twice as much, but not like 100 times more. So it is really powerful for a data warehouse. So I'm not managing the compute layer. Athena is doing that for me, and S3 is S3. Everybody knows S3. So how do you create reports? You don't want your data analyst to write SQL queries manually and get SQL query sets out as their analytical tool. So you can bring in Amazon QuickSight, which is a managed service for creating reports. That's exactly what we need. And it's fascinating that, I forgot to go on. And it's fascinating that you can use what's called spies to do the query, maybe aggregate the data, and import these aggregations into spies, which is an in-memory engine that allows you to have the data available all the time. So even if Athena, S3, API Gateway, and Kinesis goes down in a region, you can still access your QuickSight reports because the data is cached in memory into QuickSight. So this is really interesting. You don't want your decision makers in your organization wait for the report to refresh because it's down, and that happens a lot. So sorry about that. So here I have my data analyst that can now submit like a query, an analysis, or use a visual tool like QuickSight to do data exploration, see what's going on in the data, go deep dive to understand it, add filters, create dashboards. It's a very powerful tool. So my data analyst doesn't really need to know the rest of the system. He doesn't, or she doesn't need to know the structure on S3, because here I can do a lot of mapping, renaming, filtering, hiding. So as a data warehouse manager or a scientist, I can make his or her life much easier by renaming fields or removing all that complexity and just providing a totally serverless visual tool to analyze the data. And this can be like, again, 100 terabytes of data. Then you run a query that takes maybe 30 seconds. And the result of the query could be, 1 gigabyte of data. And you import the data into QuickSight, and that will be available in memory. Really, really quick data exploration. You want that kind of experience. And then I added one more branch up here, which was the optional requirement of having a real-time analytical functionality. So I brought in Kinesis Data Analytics, which is like this, let's call it application that will take data coming from Firehose, allows me to write an SQL query that will run on like a windowed slice of my data, do some aggregation, output it into Kinesis data stream, and then you can process that data with Lambda. So, and then from it, you can do anything you want. I chose to update some CloudWatch metrics. So in real time, I would see these metrics updating, and I know how many events are passing, how many events of this type are passing, or do more complicated things like detecting if there is like too many events of this kind, anomaly detection, and stuff like that. So it's not super complicated. Putting all the pieces together can get complex. But it's really powerful, and it's 100% serverless, but not this branch up here. So let me get into the gotcha section. A couple of hints that I've learned. The branch up there was not super serverless, in my opinion, because data analytics and data streams, you pay by the hour, basically. So it doesn't really go down to zero when nobody is sending events. That's not my favorite. And then the second gotcha is that API Gateway is not super cheap, so you may want to eventually goes straight to Kinesis data files instead of having the API gate in front of it. But I really like to have an abstraction for the client, so it doesn't need to know about like the SDK and all the put records, API endpoint. You know, it's much simpler to just post a JSON body, right? So if you remove API gateway and you don't have too many clients, it can get much cheaper, but then you need to have a complicated client. I cannot go into the details of Athena, but it's really fascinating. Don't forget to set up partitions to optimize the latency and reduce the costs. So basically, you're charged based on how much data you are scanning for each query. So if you have partitions, it means you can scan a much smaller fragment of your data. So it will be much faster, and you will pay much less. So if your data set is pretty big, it really makes sense to have partitions. And then I wanted to mention glue, which is not in the diagram because it doesn't have like a real-time role, but it is really useful if you want to auto-discover the schema of your S3 events and your S3 objects. So it's a really powerful architecture. If you want to get started, it's all public, so you can find a SEM template, like a CloudFormation template, to get started. It's totally open source. It doesn't contain the real-time branch up there because it's more complicated to set up with CloudFormation, but it can be added without too much troubles. So my suggestion for you is start collecting data. Have fun. Thank you.